We are starting our final part, our closing ceremony of our hackathon, and it will consist basically of 3 parts. And we will start with greetings from our partner, from Sberbank. Then I will ask representatives of all teams one by one goes here and gives a few words about their solutions. And then I will give results of the competition, and we'll arrive prizes. So first of all, I would like to thank our partners Sberbank, who co-funded our iPavlov project, and I would like to invite Mikhail Shvetsov, who is a leader chief of digital credit monitoring tribe. So he will say a few words about.
Да, добрый день, уважаемые участники. Я бы хотел пару слов сказать о тех изменениях, которые у нас происходят, новых. Сейчас мы создаем объединенное подразделение цифровой кредитный мониторинг. Сфера ответственности будет мониторинг клиентов и залогового имущества. Постараюсь показать интерес в том, что одна из целей этого нового дивизиона — внедрить 90% моделей, которые будут предиктивно предсказывать состояние клиента, и решения будут приниматься уже на основе этих моделей. Пару примеров, на чем мы сейчас работаем. Анализ новостных источников, выявление событий, релевантных к кредитному риску. К теме конференции опосредованно это относится. У нас, в частности, несколько лет назад Сбербанк расширился до группы Сбербанк. У нас есть масса нерезидентов, есть Сбербанк Швейцарии, есть Сбербанк в Восточной Европе. Возникли у нас за пару лет ряд кейсов, где нам нужно мониторить не только источники на русском, но и на иностранных языках, в том числе не очень распространенных. Вот. Прямо есть кейс, он, в принципе, не буду его рассказывать, но он был и в прессе, когда в одной сербской газете мы не нашли определенную новость, она могла свидетельствовать о том, что у нас с клиентом будет через определенное время не очень хорошо. Вот. При этом сложности перевода, конечно, и держать людей с сознанием сербского мы не можем. А вот если бы у нас были движки, которые это все улавливают и могут быстро сообщить, переведя смысл, то это было бы очень здорово. С текст-анализом связаны ряд нужных нам моделей, которые переводят внутренние и внешние источники в смыслы, которые нам могут помочь сократить значительную долю ручного труда и поставить мониторинг на ежедневную основу. То есть сейчас мониторинг происходит периодически путем получения информации, анализа человеком, а нам очень важно, чтобы это было машинное чтение и машинная обработка. И после этого, когда мы это все научимся делать, чтобы это была предсказательная система, которая в идеале работает в онлайне. Второй проект, который мы сейчас открываем, сейчас подключаем клиентов, используя так называемый бренд интернет-вещей, подключаемся к системе телеметрии, автоматизированной системе управления производством и прочим датчикам. Это очень огромная масса информации, которую, даже мы, если получим, мы не сможем распознать. Слишком много данных, но нам нужно из этих данных извлекать тенденции, тренды, а также делать из этого смысл и вовремя давать сигнал, что с клиентом происходит, что происходит с его производственной деятельностью, девелопментом и так далее. Очень много других проектов. Вот такая амбициозная 5% моделей для принятия решений. Мы эту цель приняли, и нам очень нужны молодые способные ребята, которые придут и помогут нам найти данные, смоделировать будущее состояние нашего клиента и помочь нам развивать бизнес. Поэтому много проектов мы, я думаю, проведем в начале года специальные мероприятия на этот счет. Но если вас заинтересовала наша сфера деятельности, вот Ольга Короткова вместе со мной присутствует, наш HR-партнер. Можете к ней обратиться, и мы рассмотрим возможные направления сотрудничества. Спасибо.
Спасибо, Михаил. Oops. Okay. Now we will. I will invite teams to say a few words about their solution and to receive certificates for whole team, for all the participants. So I think that maybe you can go as a whole team, or you can go just as one representative for the team to receive to say a few words and to receive certificates for school. So let's start with the first team is EORA. So that's certificates for your team.
Oh, okay, thank you. I should talk about our solution, yes?
Yeah, just like 2-3 minutes, couple of words, how it works.
Okay.
What have you used?
As I understand, nobody tried to implement a working solution for unsupervised neural machine translation because it's a hard task. We hadn't enough memory, space, time, and that's why we use synthetic corpus for increase the quality of supervised translation. And we tried different methods like back translation or filtering in the blue score. For instance, we trained 2 supervised models on, from source to target and from target to source. After this, we translate from target to source and from source to target, and that's why we have target. This sentence we brought from monolingual corpus, and we had target ground truth sentences and synthetic sentences, and filtering them for blue metrics, sentence by sentence, and try to bring the most successful translation. Okay, and as I know, before organizers hidden the leaderboard, we was on the first place. Okay.
Okay, let's see then.
We think that our method was good, but it is not a full unsupervised system.
Okay, thank you. So now, not implemented yet, team. Okay.
Hello, we are team not implemented yet, so our solution was rather okay, I'd like to say it was simple, but now I realized it was not very simple. We trained a language model on the first corpora, then we trained another language model on another corpora, and after that we initialized with these language models our sequence-to-sequence translator, which was a transformer, and we trained our transformer model such that we've used our second language model, which was language model for the target language. we've used our language model with our transformer. It was a shallow fusion, but not exactly which was in the paper it provided, but we used instead of shallow fusion with hyperparameter beta, which was in paper, we used 2 gates, and our transformer should decide which predictions to use. It was a more accurate calibration of logits, but we didn't have time to make any ablation, so we don't know whether it really improved results. Besides, we tried back translation. It didn't improve results on our validation scores, and when we submitted these models, it was the last day, and we have found a very, very ugly bug in the tokenizer. After all our training was passed, we detonized the predictions, and this step failed, and it took us billions of neurons in our brain to fix this. So, but at 8 o'clock in the evening we found this finally, and after that we submitted some models blindly, and we didn't know whether they work or not, so we don't know our final below. But on the first pair we had 23 below, but it showed after the language pair was switched, so we didn't appear in the leaderboard. And besides back translation, we also tried to use ensemble, but we submitted this solution at 3 o'clock in the morning, when it was an hour before the hard deadline. So and it failed on some mistake, and we don't know the results.
Okay, let's pray for good results.
Thank you.
And I forget to give it for the first team. I will give it. It's a game from our partners, Data Monsters.
Actually, we visited your lab on the 5th floor, and we were given already these cards.
So okay, so for your team. So now, okay, thank you. The next team is Lost in Translation.
Раз. Отлично. Hi everyone, I'm here to talk about our team. We borrowed our name from the movie title, but it came up pretty ironic to me. Let's talk about solution. In the first round we stick with convolutional sec-to-sec models. We actually used implementation from the Facebook research, and it behaved pretty good, and we took some steps to improve it. So actually we tried to replace sec-to-sec model with OpenMT, which mostly was tuning of parameters, not in a very intellectual way. So we returned to our PyTorch implementation and tried to use some improvements. As one of previous speakers told, we also tried to use unsupervised learning, and it came up pretty difficult to use. I'm not sure was it because we didn't have enough computational power, or because the styles of the parallel and unparallel corpus was very different. Actually, unparallel corpus was mostly comments, which was mostly trash. So we gave up that idea early and tried to improve our model. First we implemented back translation. We also tried to increase our parallel corpus with some data from Babel. we used library for language inference, and things were good, and we didn't even submit it yet, but after switch of dataset we actually fell pretty much in the leaderboard. So we wasn't sure what was the reason, and we thought it was something related to our pre-processing. It was either BPE or detokenization of Moses interface. So we think we fixed it in the blind round in the last hours. Also, we implemented some ideas what we didn't get the score for them, because it also was in the last couple of hours. So we implemented back translation. We tried to use parallel corpus to learn some language model on our data, but actually it's kind of black box to us because it was pretty late. So I think that's about it.
Yeah, great. Thank you. So, your certificates and your game. The next team is переводчики.
First of all, we're trying to use supervised translation. After that, we tried to back translation, but we saw decreasing of quality on validation, so we did not use it. And we implement some models who train language model on monolingual corpus and use supervised translation at the same time. We didn't know actually why it works such a way, but it works and increase the blue score. And we try to use to learn embedding with fasttext and Muse on monolingual corpus and use this embedding for our model. And we have some increasing using with embeddings. So that's all.
Okay, thank you. And so the next team is Monkey Business.
Hi to all, thanks for having us at this hackathon. In fact, we use several methods. First of all, we try to use unsupervised method, as all the teams, but we realize that it's a dead end, unfortunately not too quick. Then we try to adapt a method about style transfer. So first of all, we trained via unsupervised method cross-lingual embeddings, and then translate the source sequences to target sequences using word-by-word translation. And they try to do the style transfer so that word-by-word translated text would be similar to target sequences. But this method requires too much time to converge, so we just tried another approach. The rest of the teams, we used a transformer, and we adopt the way of back translation. We use the same back translation as the first team, but unfortunately our implementation lacks testing, and they were killed by time limit, so our final result will be without back translation. So basically that's it.
Okay, thank you. So take your certificates and your table game. Okay, thank you. So the next team is Yerevanenen.
Thank you. So we did all our experiments with Google's transformer, and we found Amazon's implementation of that, which is under the framework of Sokai. So this Sokai framework has everything you need for training a neural MT model, except tokenization. So we used NLTK tokenization, as we knew that it is the same thing that is used in evaluation. So we also tried byte pair encodings, but it didn't improve the performance on English-Russian pair. So we stayed with NLTK tokenizer. Later we realized that all these neural translation systems are kind of designed for very large parallel corpora, and they do not seem to handle rare words correctly. So instead of copying or writing some random rare word, it was just like duplicating the previous phrase of the sentence that was correctly translated. So we decided to handle this somehow, and had several attempts, like finding some types of entities, like English words with a capital letter at the beginning, and matching this in source and target sentences and replace them with unknown tokens, so that the model can learn to just predict the correct position of this unknown token, and then after inference just replace the words. And the more complex version of this, which actually didn't improve the score, was to use a technique that was new to us, although it's a very old technique. It is unsupervised word alignment. So it's a technique that gets from 90s from IBM research, and we could find a relatively recent implementation of that, which was not written in Java. It was very hard to find one, but and it actually scans the source and target sentences and predicts the alignments with using some sort of expectation maximization algorithm. So we tried to filter all rare words. So it is interesting to note that the vocabulary of the Russian corpus, or English, okay, so the source corpus for the validation dataset was had 30,000 words, and if we removed all the, so out of these 30,000, more than 28,000 words happened less than 10 times. And we saw that the neural models are not able to handle these things. So we replaced all these rare words with unknown tokens and used word alignment to replace the English translation of these words with unknown tokens, and then replace it back at the end. And this improved a little. Finally, we got very large improvement using ensembling. So Sokai has 3 implementations: RNN based, convolution based, the one from Facebook, and transformer. So we trained 3 on both supervised datasets and assembled them, and got like 3 points in blue advantage from single models. On the final day, we saw that Moses is performing much better than every single neural model on this dataset on English-Russian pair, and we found an idea how to combine these two, but didn't manage to do this with Moses. So the idea is that you can take the source sentence and translate it using SMT, and then concatenate the translation to the source sentence and train your neural model on this. So basically you can give the information from statistical machine translation system to your neural model. And I think that that could seriously improve the results, but we didn't have time to do that. Instead, we used a simple word alignment based translation. So we took every word, we used the aligner to find the translation and concatenated it at the end of the sentence, and only then trained the neural model and got a little improvement. I think that's it. So in terms of unsupervised stuff, we tried back translation, but we didn't manage to solve the problem of overfitting. So on English-Russian pair, we consistently got worse results with back translation. Or either we were underfitting, so it was not learning to translate well enough, or we saw that the validation on the real target sentences is getting higher. So I think none of our final submissions uses any sort of unsupervised or semi-supervised thing. That's it.
Okay, thank you. So now you can take your certificates. Next team is NL Processing.
Hello. We had actually two lines of work. One was kind of primary aligned to the subject of this hackathon to build a full unsupervised model and then train it on this small parallel corpus to get a better result. So that's something which we did, but we are not sure what was the result because the final implementation was done like end of the day, like very last moment. And the second line was to attack the build a fully supervised model with extra like language, extra corpora, but that's something which we kind of not really succeeded to do. That's basically what we have done in the last 5 days.
So Babeloids, the next team.
So our main idea was to use a transformer model, but like not the original one. We extended it a bit, maybe using materials from other papers, like a multi-headed transformer. We had one encoder and two decoders for two target languages. Encoder was meant to encode from both languages, both English and Russian or whatever they were in the system. For that we used parallel embeddings using views, so that similar words had similar embeddings, and we used transformers, basically positional like independence. So we trained positional embeddings differently for two languages, so that it can ignore different order of words or some languages. We also experimented with pre-training our model on English-Russian pair and using the weights and the embeddings as like target, I don't know, so that we aligned not like English Russian using views, them both onto some target embedding space for which our encoder was already pre-trained, so that it can improve the speed of convergence. I don't know. The only problem was that we had very bad technical problems. We couldn't make Docker work, so the thing that is on leaderboard is a simple cat baseline. We simply copied the text over and that's it. Our good and interesting solutions and models were no use because we couldn't handle Docker.
Okay, thank you.
Thank you.
The next team is color print. So the whole team, one person is not here. So then the next team is OMG WTF. Anybody here? Okay, so now we are going to the most interesting part of our hackathon. So, and first of all, I would like to ask you, what do you think? What is your hypothesis? What was the first language pair during this week?
English-Russian.
Other ideas? So, so more ideas?
Maybe English and Esperanto.
Not yet, not yet. It's close, but yes, maybe. Yeah, European. 2 European languages.
European language? Italian?
No.
Vietnamese? Some Scandinavian? Catalan?
No. No. So I will show you. Just no. It will be too long for you to guess this. Oh, sorry. So 1 million Latvian sentences, 1 million English sentences.
It was the first language pair, right?
Yes, it was the first.
Using the parallel
And so now we quickly go through the.
Was it provided by Google.com and was the mail portal?
No.
And both parallel and Molingo was from you, yeah? They all from you.
Okay. So the second. Now we will go quickly through the results. So on the third 3rd of January was Переводчики on the first place, then NL processing, then Babeloids. So it was like now we're just going like reviewing our history. So when we have more teams on board, Lost in Translation on the first place, Переводчики on the second, and what EORA means? Success. NL processing, Babeloids, color print, monkey business. Not implemented yet. So now we are moving closer. Lost in Translation, your EA not implemented yet. Переводчики, monkey business, E1, and then NL processing. I forget where is my slide with the next language. I don't want to after that. Yeah, so I still have one more slide. So Babeloids, color print, OMG, WTF. So the last day before the final submission, the leaderboard was not implemented yet. Lost in Translation, EORA, Переводчики, monkey business, Yerevan NL processing, Babeloids, color print, etc. So now let's guess the second final language pair. No. Okay, English something. Yeah. No. Yes, it's Asian language. No. No. English, Asian English. Yes. Yes. It was booking corpus from English to Korean. So these are the numbers for the last data. So now we are going to the finals, to the leaderboard for the finals. And we will start from the first 3 places. Third place, Yerevaninen. All the teams goes here, who are here, yeah.
Do you have medals on DeepHack medals.
First.
And that's your prize for the third place. Thank you for going to us for this time too, and we are expecting that you will come to our next competition. I think so, yeah.
So the second place is, and actually, as you can see, that blue score is pretty good, I think, for this task. Not implemented yet.
Так, кто сейчас показывает?
Okay, thank you guys. And so before I will announce the first place, I also want to say a few words and thank all of you that you have participated in our hackathon and our school and in our competition. And also I would like to say that now in our iPavlov project, we are, as you have seen, that we have our first version of our library, and we are starting to doing applications based on that. So we are looking for people who can join our project and applying our library to different use cases in the wild. So if you go to iPavlov AI, there is an email you can write to us and send your CV and any other information you want. And I also, as we usually do on our hackathons, after we will finish with the prizes, I also would like to stay here for a few moments and to have something like exchange of opinions or like something like a round table. So I would like to ask you to give some opinion about what has happened during these days. But the most important moment of our competition, I think it's announcing of the first place. And who will be the first? We will see now. And it is Lost in Translation. So I think that choosing the right name is a good idea. And the first prize is journey to ICML, travel grant for ICML 2018. Hurrah! Thank you. На здоровье. Okay, and now the fourth and fifth place. It's переводчики. And in the final table, you will see more numbers after the point, so you will see the difference between places. And actually, you can see that there is quite a big difference between like a third and the first place, because blue is more than 30 for the first place here. And here is a full leaderboard. You can enjoy the numbers you have. So basically it's all. And I congratulate everybody that this week is over, and you have gained, somebody gained prizes, but I think that everybody gained great experience and hands-on experience with machine translation and with many different interesting algorithms in natural language processing. So now let's maybe, I don't know, we can do this in Russian if you want, or you can do it in English or in Russian, and you can give some words about what has happened here. And this is our partners, and you can use also some from one of our partners online consultations with this promo code. So okay, but I hope that nobody will need this after our hackathon, in spite of all this thing that's happened here. So just lost in translation. Just your feedback about what happened here. What was your experience? What do you think was good? What do you think was wrong? And what you have like gained? What you liked most from the hackathon?
Okay, so I'll first try with some unpleasant things. So basically it was that the hackathon was intended to be on unsupervised learning, which was quite of hype at the moment, and in this particular setup it was fairly impossible to reach good unsupervised solution. So maybe I would advise to eliminate parallel corpus or make some other accommodations on that matter. Besides that, we really enjoyed lectures. It was even the lectures that I heard before. For example, attention is all you need. Hearing it from one of the authors of the article was pretty great, and we had fun. So it was quite hard to be working for 5 days. Actually, we was I can't say some words. So it was. It is pleasant to us now because we won, but we were quite angry sometimes, especially when we fell down the leaderboard and we couldn't figure out what happened, and all this Docker and all these things. So I think after all we will have good emotions and good memories about the hackathon, and we'll came again, but we'll expect to have interesting problem that it won't be regressed to more simplistic setup. So it's about it. Thank you.
Okay, thank you. So maybe you can just pass the mic on the left, and do anybody want to say a few words?
I would like to add that one thing that this hackathon really, I don't know if needs, but would be very helpful is like a baseline submission, a Docker file that actually works, so that we don't have to tear our hair out to make something run. Because it was 90% of the time we were struggling with Docker, and only 10% of the time we were actually solving anything, and we couldn't get it to run. If there was like baseline Docker file which had CUDA running and maybe something else, even if it was like empty and not a solution by itself, if there was an environment on which we could build upon and not start from the very beginning, it would be very helpful. Maybe something for the next time. Baseline submission.
Okay, thank you. But have you used for qualification round also Dockers or not?
Yes, but it was much easier that time because, I don't know, we weren't really that... our model was not that complex and did not use that many things because we could just run basically somebody else's code very simply, and now we have to create something on our own and install all these dependencies and all this stuff, and it wasn't very easy to get it to run, and also CUDA, which also cost us a lot of time.
Okay.
First of all, I want to thank you, organizers, for that event, and just a few words. It would be nice to have like a separate system with toy data just to test your submission, because on Friday many teams couldn't get if their submission works or not, waiting many hours before their submission is being tested. And also it would be nice to have rules announced before or during the hackathon, like when your submission fails because there is a 20-minute limit on checking, and you get that information after the deadline. Something not that good.
Yeah. Okay, thank you very much for the feedback.
Yeah, so again, I will start from the, I think, the worst part. So I think there was a lot of unnecessary stress in the evaluation process. So I think it was like, so the system, just like the previous person described, so you had a small check, a small subset for checking, and you used it to not leak the other logs, but it was not like explicitly written anywhere. So basically it was the analog probably it's very hard to set up an evaluation for tasks like this. I mean, I didn't come up with a better idea actually, but I think that could have been improved so that the submission evaluation setup is explicitly available to the contest participants. So I think this is the only problem I can see in this event. So everything else was pretty well. So both the organization from different aspects, and obviously, at least for me, the most important part are the lectures. So you had a pretty good lineup of people who, I especially liked the Roman Paulus lecture that basically summarized the whole MT research of past 2 years in 1.5 hours, and it was like very informative. This was helpful for us to learn about some old techniques from machine translation that are somehow fading away because of this deep learning hype, but they still seem to be very important for low resource payers. And I think the QA sessions with the speakers like Salahuddinov or Cho were very impressive, and today's lectures were pretty good. So I think in general it's a success, and thank you for this.
So on this side.
Well, everything was pretty cool. People were trying to help you if you need help, and if you have any problems. One weird thing though was that usually on a hackathon you concentrate on the problem, on the task you're trying to solve, and sometimes we had to skip lectures to make our solution better. I don't know if it's our problem or not, but maybe there should be some regulations about attending it. I don't know.
So we need strictly enforce visiting lectures, or what? What we should do? And disqualify teams if they are not attending.
I don't know. That just was my personal pain, I guess. Okay, that's all for me, I guess.
We skipped almost all lectures on this hackathon because we had to we had to make our solutions, and we didn't have time to visit them. So yes, I think something can be made about this format, because it is maybe rather difficult for lectures to give the lectures when nobody is listening and everybody is sitting behind their computers and working.
Okay. So we will shut down internet and turn all the power.
I honestly don't know what can be made about that, but
yes, maybe.
Or giving lectures during dinner time when you are eating and you have time to listen something. I don't know.
Also, the testing, the queue was way too long. I think it would be optimal to divide submission into short ones and a few long ones, because most of our submissions just failed on simple stuff like tokenization, which can be handled on small data sets.
Mm-hmm. Okay, it's a good idea. Thank you.
I should say a lot about testing system, and the testing system was hackable. So you actually could know the language pair in one submission. So there are several types of attacks on the testing system. One of them is on our poster, but it is not optimal actually. You can do a time attack, so you can know the language pair definitely in 100% probability.
Okay.
I don't know if it's safe to say, but the worst part for our team was the Perviatel, so we couldn't stay here longer than 10 o'clock or something.
Yes.
And working in dormitory is not the most comfortable thing to do. I know it's not your fault. I mean, just saying.
It's just law enforcement from
I see.
university.
And I think that's only downside.
We will think about this for the future events.
Yeah, I don't know.
So anybody else?
I just like to say that we said a lot which could be improved, like the submission system, the lectures, the place, and everything could be improved. Yeah, but this was perfect, really. Thank you.
Thank you. So then I suggest to finish all the feedback on this positive one. And so let's take a picture now of all the participants. So what we should do? turn off translation.